sure.
Cancel the video for next time. I'm starting it again. It's tough.
What your question, but I think that sort of question would be better served during, if you would come to my office hours tomorrow and we can talk about it. Because I'm not sure what you're doing. I would actually have to look at what you're doing. Okay? Any other questions? Okay, so the last problem in that quiz, which I heard was a mixed bag in terms of success, is this problem right here. So we're given below a proposed modification of the van der Waals equation state. Is this modification reasonable? Explain carefully, you basically have to do it mathematically. So what's the first step for this problem? Well, what's the idea? What's the plan of attack?
Show that z equals 1.
Pardon?
PV over T z
Yes.
PV.
Yes. And so once you got z, what do you do?
Show the
Take the limit as v approaches infinity.
Why are you doing that?
I did it because this guy did the actual increase of the bigger gas for.
Okay, and why does B correspond to, going to infinity correspond to an ideal gas?
Because you have, at infinitely large volumes, you have no interaction with molecules.
Right,
Ideally.
right. That's the idea. Did everybody get that?
Yeah.
Well, obviously it is out there, but if everybody got it, then the success rate would have been higher than
I get it now.
what was on the quiz. So if there's confusion here, now's the time to ask about it. Yes. After that, it's just math, right?
Yeah, so I think that a lot of us got the answer. We just didn't explain it in the way that the rubric asked us to. So I have a question. When you're taking the limit, what were you taking the limit of?
Limit of volume going to infinity. And that's why I probed, Brody why, and do you understand why it's the volume? Well, no, you understand it.
I don't. And then what is, so I know z is supposed to go to 1, but I thought z was also equal to the PV over nRT.
PV over RT, that is true, but the bigger problem is that I'm giving you volume, and you don't know why the volume, if I understand it correctly, correct?
Yeah, but I also got
By the way, what's your name?
McCaden.
Okay.
Yeah, so when I wrote z equals PV equals nRT,
Or Z equals to PV over RT. That's
so no n. So
That's only when you're talking about PV is equal to nRT for the ideal gas case. Okay, but I never told you, so we're taking it, let me give you the answer and tell me if it makes sense. What happens when you're having, do molecules interact with one another when you have an ideal gas? No, right? And what would you need for the molecules to not interact with one another? What, if you make the volume really, really small, will the molecules interact with one another?
I would think so.
Yeah. But if you make the volume really, 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 really large,
So that's why we're dealing with
yes, that's why you're doing the limit, because you're looking at, I don't care if you're talking about cottage cheese. If you make your cottage cheese so, in big volume, so large, then the cottage cheese molecules will not interact with each other.
Okay.
Okay?
Yeah.
I like cottage cheese. So, although I like my cottage cheese molecules interact.
It's actually a lot of protein.
So that's it.
Cottage cheese has like a ton of protein in it.
We're taking a little bit of salt, and we're taking a little bit
Yeah,
of
with
salt
the
and
pepper and salt.
so that the particles don't interact.
I'll make it for you for record. It's not as good as baked beans. It's up there.
Conceptually, that makes sense. It's just mathematically when you are dealing with an ideal gas, because that's what I took away from this was like you're comparing it to, like, if you were to do that with an ideal gas, take the volume to infinity, I just don't understand mathematically where that lies, as what, at least.
So do the limit as u goes
So,
infinity.
this is not an ideal gas
Yeah.
problem, right?
Yes.
Because z is equal to
If you would
p
have an
over
ideal gas,
RT,
PV
right?
equals RT,
So then you
or
would
if you have
exit
one
that
mole,
equation.
that's
You
always
have
true.
to,
Right?
Yeah.
So you make p over t equals.
I get that.
Yeah, I don't quite get the question.
The reason we're doing that is that, you make that equation reasonable. If you're saying v equal to infinity, then that equation should return to something that is an identity. That equation should be v over RT. Yeah, that's the reason why
Minus a over
to send it to infinity, to make sure that it's reasonable. So if you
you
compare it to
divide everything by RT.
yeah, does that make sense? Yeah, that's
And
what
so
I
then
mean.
it becomes 1 over e minus b minus b minus a over RT e squared.
Yes and no, I
And then
think
you
I'm
multiply
just-
everything by
I'm just
Like, we're,
misunderstanding something, but it's
you know,
okay.
in a certain
So
limit,
divide
this,
everything by RT.
if we make the volume, we're kind of
From-
trying to, mirage this system having an ideal gas, by making the volume.
Yep, I get that, like, I get the reasoning why we're taking it to infinity, it's just
Okay.
mathematically, it's the, but there's just, I'm just
And then you
misunderstanding.
multiply everything.
It's okay, I understand
So it's
conceptually.
PV over RT.
Okay, well, I'm gonna help do it mathematically, perhaps that will help.
You probably
Is
wouldn't.
there any other, is that, so,
Yeah.
let me repeat the third time, any other?
Over v RT.
Is there, it's
So then
clear
as
to
the
everybody
limit
why we're
of
taking the
v
volume?
go to infinity, that's 1
All
over
right.
infinity, which is 0.
So mathematically, we have P is equal to RT over V minus B minus A over B squared.
Yeah.
So we
So I
can
think
get
you'll explain it more,
compressibility PV over RT is equal to V. What is PV over RT? So we're gonna have V over no, that would be only equal to 1 if we would have an ideal gas. Oh. V, so this is gonna be P. So this is gonna be equal to V over RT, P, so this can be RT over V minus V
I said horses on my
minus
head.
A
No, no,
over
no.
V squared,
So Super Bowl.
right? So this is gonna be equal to 1
Did you get
over V minus V minus A V over RT squared. So we're left with, this is going to be equal to 1 over V minus V minus A over
How
RT.
difficult is it to ride a horse? Not it is.
All
How
right.
difficult is it to make
So,
a joust with another horse?
now we just have to look at the limit of this, bill.
No, if I want to ride a horse, well, another guy rides a horse really fast, that will have big poles sticking in each other.
So,
I can totally do that.
we therefore we want to look at the limit of V goes to infinity of
Look at the
V,
little jockey hat.
which is equal to the limit
Oh, this is what he's doing.
of
So
V
this is
goes
what we
to
just did.
infinity of 1 over 1 minus V minus V, which is
So
equal
then he
to
also have to
the
write
limit
that part where he says the limit of z is
V goes to infinity of A over R T V. What's the limit of the first term as V goes to infinity? 0. What's the limit of the second term? 0.
Give it more, like you have to write the limit.
0. Reasonable. No.
Just making sure
Not
it's-
reasonable. Should go to 1.
And then it doesn't go up. Yep, perfect.
Check it out when the van wall equations take. They will,
So smart.
they will go to reasonable.
Genius.
Okay? Any questions? All right, for dessert, of this thermodynamics party,
Oh, shit.
I thought,
What's the continuity?
like, I'm not gonna do them all, but I will say
So the
that
delta
all these problems that, especially the star problems that we talked about in the previous assignments, they're all on Canvas. Like, well, the ones that ask for the problem
So, I'm sorry, I just asked a question related for this last topic.
For the.
By the previous one.
Sure, okay.
So since we got 0, in this process, like, we're pretty much looking at a non-ideal gas trying to get to an ideal condition. To be able to calculate that and get the reasonable C value. So
Right.
in this case, it concludes that this is for sure that.
Not reasonable, because it doesn't, even if you look at a certain limit, it doesn't behave like an ideal gas.
So we can't even get to that condition.
No, so if it does, so, you know, so if this is just like the nail in the coffin kind of thing. If it can't even describe an ideal gas, how can it describe a non-ideal gas? Right? Is that clear to everybody? Yes? Okay.
What was it?
I kind of like to go through, so problem 11, problem 12, and problem 13 are all nice problems. But I want to go to problem 15, and I was surprised that I didn't get any questions, my office hours. Maybe one person asked a question. I want to consider this following problem. And I want you tell me how you go about solving this, before I solve it. So we have heating a home, something that's kind of important these kinds of, in a couple of weeks. To increase its temperature must be modeled as an open system. Because the household air and constant pressure results in leakage of air to the outdoors. Assuming that the molar properties of air leaving the home are the same as those of air in the home, show that the energy and mole balances yield the following differential equations. And here Q dot is the heat rate transfer to the air in the home, and T is time, quantity Q, B, N, and U refer to the air in the home. Okay? So, ideas of how you do the problem.
Which assignment is this?
Assignment 1.
Okay, thank you.
Ideas of how to do it? Okay, if there's no suggestions, I would suggest that we take a good couple of minutes for you to discuss how you solve it.
The worst part is we've done it.
Should we start with the individual ones?
Yeah, that's what I was thinking. Especially get the Q value right there.
Are we doing 12 or 13?
12, the heating of the home. Have we not deployed away the gavel yet?
You would?
Oops.
No, it's still there.
Elizabeth might be mad at me. No, it's the A key one, and she keeps reminding me, like, Henry, you need to put it away, and I'm like, oh yeah, I'll totally put it away, and then I keep forgetting, and Q just used it, so I can't hide behind the fact that it's hidden up there.
It is now. Alright, so heating of a home to increase temperature of the models in open system. Constant pressure to molar properties, air integrated heat transfer.
Yeah, that's fine. Yeah, but it goes constant question.
The molar properties of air leaving the house are the same as the air in the house.
Which equation do we have for Q? We know that Q is equal to CV dt plus PV dt.
That's what I was thinking, because we got the PV. No, it's the N.
Yeah, but that's up to you assume it's
So it is just you
Which one is this?
continuity.
So, U1 equals U2. Like, which one?
U1, A1, it's the same we used for that.
Oh, I see what you're
That's
saying.
the entire continuity equation. I thought there was more to it.
Yeah, okay, that makes way more sense. The U1 A1 over V2 is equivalent to U2 A2. That's the continuity.
Yeah.
Yeah.
It,
We
in
have to
its
use-
entirety. That's it. But
Yeah.
it's like,
Yeah, I thought it would be more terms. But I
You know, 'cause
don't.
in transports we usually just do V1 A1 is equal to V2 A2 because we get to ignore specific volume.
how do you know that?
What? In that class we just ignore because we're only dealing with a single state just going through a pipe or something.
Okay. Everyone's did well on the last quiz that just came out.
What?
Transport quiz just came out.
Yeah. How did you
You're doing
do?
better on the quiz.
Everyone got higher than 95% for like one person.
Nice.
Nice. Probably me. High five.
No, not for that.
Wait, no, like, why not? why won't you? I just lost. I got 5% less than everyone else, and you're not going to high five me? I don't know.
You haven't even looked yet.
Yeah, but you're not going to high. What if I did? And then you did that high five, that personal connection, and you just rejected me
That this is,
and ignored.
that this one is going to be the exam.
So he's
There's
saying
a good chance.
one of these will be the
Yeah,
ones
but
that.
you know what's going on.
Actually, yeah, because that's what he did the that quiz where we has the limit up to Z. So genuinely, we should be really paying attention to this. But also, we know the answers to all the ones that are through the problem-solving procedure for.
The thing is, can I have a picture of what it was one or the first assignment thing? Because I did everything right, but I turned in the wrong questions. So they said I could redo it, but like I have to redo it.
Yeah.
It's much quicker.
I'll send it,
Like,
yeah.
base what I did off of what everyone else did. Because it's either 1 point or 0.
Yeah, Dan will send you his because his is way better. But
It's not like, yeah, you either get a point for doing it or 0 points for not doing it, and I did the wrong problems.
might as well.
And it takes forever.
So this is how I did 12. So we're gonna have the general energy balance.
Yeah, that makes sense.
Yes.
So it's that if it's a constant, a steady state plus the delta m dot times h plus 1/2 u squared plus z times gravity.
How do we assume steady state though?
It's assumed. I mean, it's steady.
It doesn't mean anything. It's steady.
I mean, it's a house.
Okay.
That doesn't mean a steady state. If you turn on the furnace, it's not a steady state anymore. You have heat going into the system.
Any questions that
But if heat leaving the system, that's cute.
Yeah, but you're not the system rate.
And it's all fair game.
So the change in energy is not going to be zero.
So if you want to study effectively for midterm, going over the problems of the homework is a good idea.
Okay.
And understanding why, but there's also some problems that are
I'll have to double check.
multiple
I think it's just this
for
asterisk.
these kind of
I'll
problems.
check if we-
So with that being said,
It is not steady state. We literally we need the NU. We cannot rely on
there
steady state.
will most likely be now multiple choice.
Darn it.
So, let's go about how to solve this. So the first, so I want to do it for the problem, for using the problem solving procedure. So here, for the first step, we read the problem, so that's done. What are we doing? We are heating a home. And we want to identify the heat loss. And we have, we have a constant pressure, and we're dealing with an open system. Okay, 3. dot and alpha. And what do we want to find? We want to find the heat we want to get.
Anyone else? Because I need the counter punch that way. Oh, I can put another grenade.
The heat was on the home. How are we going to solve that? Well, the first thing that we want to do is to use the corresponding anti-balance for open systems. So, part 5. We will start. And imbalance. For an open system. And then simplify the expression. This expression. And use the continuity equation. As well. So we have that minus delta and dot for the flowing streams is equal to the NT. This is the continuity equation. Okay? So, there's no additional information. Well, the only additional information that we need to remember that H is equal to U plus PV. And the last assumption is that we assume that the height change is negligible. And there will be no velocity change in there. All right. So with that being said, let's go to this continuity or this equation. So we have D and U dt is equal to minus delta
Okay.
H plus 1/2 U squared plus UG n dot over flowing streams. So this we directly argue to ourselves doesn't matter. And plus Q dot plus WS dot. So WS dot is certainly equal to 0, but Q dot is not equal to 0. We're going to have a heat loss. So we have that D and U dt
Why
is
is Q not zero?
because there's going to be a heat loss. So minus H m dot flowing streams plus Q dot. So now also the change in internal energy of the system cannot really be assumed to be 0 since the system is not at steady state. So we can use a chain rule such that we have U dn dt plus n du dt is equal to minus delta u plus pv and dot of the flowing streams plus q dot. And so we can write this as minus delta n dot u minus delta pv n dot plus q dot. And we can further write this as minus note that by separating out the N's and the U's, we have that U and V are for mole quantities or properties. And therefore constant. So we have that, therefore, U dm dt plus N du dt is equal to U dm dt plus QD dm dt plus Q dot. And here I've used the fact that this minus delta n dot term is going to, or minus delta n dot term is going to be equal to dm dt. So here we, since minus delta n dot is equal to dm dt, that's the continuity equation. So in particular, we're going to have that this term is going to cancel out with that term. So we're left with N du dt is equal to PV dn dt plus Q dot. So we get that Q dot is equal to N du dt minus PV dn dt. Is what we have to show. So it's a nice problem. So again, I would invite, I think I put all the solutions for the problem solving procedures that require problem solving procedure already online. And I thought of something solution. Yes.
I am a little confused about the continuity equation because I thought that was relating velocity and area.
As a consequence of the continuity equation. It's not the continuity equation per se.
Okay.
Look at the textbook and you will verify it.
Okay.
We expect you to do the problem solving procedure
Yes.
on the
Can you
exam.
go back up to the picture you drew real quick?
No, he already told us. He
Oh,
would open
okay.
it.
And then it's only the asterisk problems that are going to be on the exam.
Not
What?
regular picture.
He said
Oh,
only
okay,
asterisk
never
problems,
mind
the one we have to do problem procedure on the
Thanks, that's
homework
it.
that's going to be on the exam. Did he say that? I don't remember.
So I kind of back with this problem, but do you have any advice for solving these kind of problems in general or just general math or anything?
Well, I would guess the thing that I would just advise, it's kind of already hinting in the problem, if you look at the problem statement. Where is it? Just read the important parts of the problem. It's already giving you hints of how to solve it. You know, show that the energy and mole balances yield. So it's kind of already hinting that you have to use the corresponding continuity equation. So and then the same thing as the previous question when it's saying, it was asked why a I think it was a TV diagram because one process was isothermal, one process was a constant solvent. So usually the problem is worded in such a way that gives you hints to how to start it or try it. Okay. All right, I'll stop there and I'll see you in class tomorrow and I'll be sure to give you.
Cool. All set? Cool. No, there's still half an hour left.
I was prepared to see you until tomorrow.
Yeah.